worksheet, like right away. Let me just explain certain things. Just as a reminder, congruent, now I know we talked about congruent, we may have a symbol. Congruent means the same shape, same size. The naming could be different. You guys notice I have one triangle RQP, the other one's BTS. So the naming can be different, but it's the same shape, same size. Right? All the measurements are the same thing. That's congruent. But now for the beginning of this semester, we're going to move into what we call similar, or similarity. So similar are two triangles that have the same angles, or triangles or polygons, any shape that has the same angles. You guys notice B with E, A with D, and C with F, the same angles. So the angles have to be the same, but the size, the measurements of the sides can be different. Right? The angles are congruent, but the sides can be different. The only thing on the sides, though, they are what we call proportional. In mathematics, we call proportional. What proportional means is, let's make a fraction. So I have three sides. I'm going to make three fractions here at the top left. If I had four sides, four fractions. So I'm going to make three fractions. Looking at my small figure, the sides, let me write it from small to large. So 6, 7, 10. Right, I wrote my numbers from small to large. And then on the bottom of my fractions, I'm going to write the numbers of the other triangle from small to large, 12, 14, 20. And we call this proportional only if all the fractions reduce to the same thing. And if you notice, all of them reduce to 1/2, so they are proportional. So the angles, for similar, the angles have to be the same, but the sides have to be proportional. Remember, what I mean proportional is they simplify to the same fraction. Right? 1/2 in this case. You guys might be, well, how are we going to use this in how to solve for things? I can give you two triangles, and I will tell you they are proportional. They are similar. So because they are similar, and I have two sides, I only need two fractions. And if you notice on the top fraction, I'm going to write 6x. Right? One triangle, 6 is the small side, x is the big side. I wrote it from small to large. At the bottom, I'm going to write 4.5 and 6. The small side is 4.5, the big side is 6. So, and I'm saying they're proportional. And then back in foundations, or part of algebra 1, they teach you guys how to solve proportions. Two fractions equal each other. You just cross multiply. 6 times 6, and then so 36, and then 4.5 equals x. So we have the 36 equals 4.5x. Divide both sides by 4.5, and x equals 8. Right, so this is how we're going to solve this. So now that we saw what proportional or similar figures are, let's take a look at our assignment. Let's take a look at first question. The instructions are state if each polygon are similar. One thing is that I check my angles. I notice that the corner angle is 70, so it looks like the angles are the same. On my sides, they all have to be proportional. So I'm going to write, if I can write on this, you notice from my small figure, the numbers that I have are 4 and 5. Right? Obviously, they have on one side, they repeat on the other side. So I'm going to make two fractions, and I'm going to write 4 first, and then 5 after. Right? I'm going from small to large. From my other figure, if you notice, my numbers are 8 and 10. Right? 8 and 10, they repeat over here. I'm going to go 8 over here and 10 over here. Are my fractions proportional?
Yes.
Yes. Do they simplify to 1/2? So the question is, stated the polygons are similar. I'm going to say similar. Yes. Yes, they are similar. Remember, the angles have to be the same, and the sides have to be proportional. Let's take a look at question number 2. I see 125 degrees, I see 55, but if 125 was to be copied down here, because if you notice it's not the same place, Remember, in a parallelogram, they have to add up to 180, 125, and 55. They do add up to 180. So angles-wise, we're okay. The only thing is that on sides, if you notice on my first one, all my numbers are 4. So they're all the same thing. I see the second one, my numbers are 8 and 10. Like if I was to make two fractions, because 8 and 10 are different, so I'm going to make two fractions on the other one. If I choose the corresponding numbers, like I'm looking at 8 and 10 here, if I choose the corresponding sides, are going to be 4 and 4. Are those two fractions proportional? No, they're not. So then, not similar. Remember, angles have to be congruent, but the sides have to be proportional. Right? 4 over 8 is not 4 over 10. So any questions for the first 10?
If it's like 1/3, that's still not.
As long as it's like 1/3 and 1/3, you're good. Okay. Once it's simplified, as long as it simplifies to the same thing. Alright, now looking at number 11, the direction says the polygons in each pair are similar. Since we are told they are similar, we know the sides are proportional. I'm not going to get 3 fractions, I really just need 2. Right? I know they are proportional. Find the missing side length. So from one figure, I'm going to use those, not this 5. I'm going to use these 2 numbers. Right? The question mark, I'm going to call it x. Looking at the figure, let me just say x over here and 7 over here. Right? X seems to be smaller than 7, lengthwise. So at the bottom of my fraction, I'm going to write 24 and 28. Right? X is corresponding to 24, 7 is corresponding to 28. You can always simplify your fractions. So instead of dealing with big numbers, let me call this x over 24 is equal to 1 over 4. Right? 7 over 28 is 1/4. If I want to make this even easier, like I want to work this out, I'm going to call this x over 6 is equal to 1 over 1. Keep in mind that the 4 and the 24, I'm going to divide each by 4. Right? You can simplify up and down, like I did on the first fraction, and you can simplify side to side. 4 and 24, I simplified it to 1 and 6. The only way we cannot simplify is the way we multiply. Since we multiply diagonal, that's the only way we cannot simplify. If I cross multiply, what's x? X equals 6. If you have calculators, I guess from the first part, you guys could have just gone 28x, and then 24 times 7, which is 168. Divide each side by 28, and x equals 6. Right? You guys can do that if you guys have your calculators, easy to deal with big numbers. But if you guys don't want to deal with big numbers, you can simplify your numbers and do it by hand. Let's take a look at number 12. My 2 numbers from here are going to be these 2 numbers. So for my fraction, I'm going to say x and 40. What are my numbers at the bottom? 18 and 48. Since I want to simplify my numbers, 40 over 48, let me divide each by 5. By 8. So 5 over 6. And I'm going to simplify the fraction. I can also simplify side to side. So the 6 with the 18. 3 and 1. So just to make this a little more clear, I have x over 3 is equal to 5 over 1. Just to make it clear. So what's x?
15.
X equals 15, yes. I just simplified my numbers. All right, any questions up until number 20? The idea is the same thing for 21. I'm just not going to make the simple x. Some of them are going to be a little more complex. Let me skip 21 because that's an easy one. Let me take a look at number 22. My two measurements that I'm going to use from the top figured are 35 and 40. From my other figure are going to be 2x plus 2 and 16. Obviously 35 is less than 40, so I'm going to write 35, 40. So I wrote them from small to large. What do I write at the bottom? Which one's smaller, 2x plus 2 or 16? 2x plus 2. I think 40 over 16, we can simplify it. Let me divide each by 8. So we have 5 over 2. I can simplify the 5 with the 35, right? Side to side, I can simplify that. But let me not do it. And I'm going to show you guys why. I know when I cross multiply, 35 times 2, that's simple. That's just 70. But when I cross multiply here, make sure the 5, you multiply to both. So I'm going to have 10x plus 10. Once again, the single numbered, make sure you multiply it to both. And when I say both, those things separated with the plus or minus. So I can then make sure you multiply it to both. All right, now my plus 10, let me move it over here as a minus 10. So I have that 60 is equal to 10x. What's x? 6. Just one thing, when you cross multiply, and one of the things is it's a complex, it has a plus or minus in there. The single number, the 5, the single number, make sure you multiply it to both. Don't multiply it only to the x. Multiply it to both. Any questions for the work? We're good. All right, this week we're going to be looking at similarity. I know I don't have my board completed because I think I'm still talking to people from the office. I think they want me to test you guys on what you guys know so far. So they want me to give